Hi everyone, welcome to our bonus module of LLM Zoomcamp. In this bonus module, we are going to talk about agents. When we launched our course this year, a couple of weeks ago, I think it was one month ago, everyone was asking, like every second person in the Q&A section was asking, hey, but what about agents? What about agents? And the answer I gave back then was that agents are still actively evolving. So it doesn't make sense to invest a lot of time into creating content, which will become obsolete in 1 year. But I already had some materials, and I thought, how about making this module lightweight so I don't put too much effort, but at the same time share with you what I already know, what the content I already have. And we do it not by creating a module like we typically do, but we do it live, like workshop style live, workshop kind of live, right? So we'll have this module. For me, it's a little lower effort to record this. So next year, we are probably going to record it anyways. And for you, I hope it will be quite useful. So the content for this workshop slash module is already in 0A agents. So we're here now. We just finished week 2, module 2, sorry, and we're starting module 3. We still need to finish a few things for this modules, and I didn't want to change like the numbers. So if agents become 3, then it becomes 4. So it's a lot of changes. So I just called it 0A agents. So this we can treat it as a bonus module. So all the materials for this module will be here. And right now there's nothing. But what we will do in this bonus module is we will explore Agentic RAG. So we already know what RAG is. This is what we covered in module number 1. I will briefly talk about this also for those who are joining this from YouTube, for those who didn't watch the first module of the course, and for those who watch in recording and who already know what RAG is, you feel free to just skip forward. So, but it will be a very quick and basic introduction to RAG, and then we will talk about advantages and disadvantages, also downsides of RAG, and then how we can make this RAG agentic. And we'll also talk about agentic search, and we'll also talk about function calling. So for this session, I use OpenAI. In principle, it should work with any other LLM provider. I have not tested it with other LLM providers, but it should work with Anthropic, it should work with Gemini, it should also work with Grok. It should, but I have not tested it. So if you test it and it worked or it didn't work, let us know in Slack what was your experience. But here I'm going to use OpenAI API for that. The function calling part is what might not work with other LLM providers, but the rest of the module, the rest of the content I present here is going to be provider agnostic. So it will work across on any platforms. And first we are going to implement a small agent ourselves, just to understand how they work, and then we will use this function calling that I talked about. We are not going to use any framework, so we're going to implement it ourselves, just using prompts first, but then we will use OpenAI SDK for the function calling part. But before that, what we will learn will be enough to actually explain how these things work under the hood, so you will be able to use any framework. Okay, so let's start. And first, I want to show you, not this one, the links. So, David, I don't know what's happening. Anyways, so the links that are important here, we have this workshop repo and course repo. So this is what we're going to follow along. Yes, go to site. So I already have it. So in this workshop, what I'm going to do is just copy paste things from here to the notebook I prepared. So there's an empty notebook. I'm going to copy paste some things from this workshop. You can follow along. because yeah, you can just copy paste the same things. And some things I'll do live coding, for some things I just copy paste. And yeah, so this is going to be the basis for our workshop today. And the course content I already showed. It's the second link, course repo. This is where you will find this agents module. Okay, let's get started. And first I want to talk about RAG. So we already know what RAG is, for those who watched the first module. And for those who did not, Rajat, I will not send it. You will find them in the description. So you just click here in the description, you'll find the links. So RAG, as we saw, consists of 3 parts. So first, we perform search, and it can be any knowledge base we can think of. In our particular case, we used min search, which was a simple in-memory implementation of search engine. Then we used text search in Elastic, and we also used Quadrant in module number 2. We used vector search from Quadrant, and we also looked at hybrid search with Quadrant, right? So there are many different options we can do search. So this is the first function, right? So we have a query from a user, and we perform search, and then we build a prompt. In this prompt, we get all the context we need to be included in the prompt. Otherwise, without this context, we will not be able to answer. And last thing is actually the prompt we built, we send to an LLM. So we have seen this, and this is very simple basic implementation of a RAG with 3 parts. And I'm going to quickly implement this for those who don't know RAG, but we have done this already in the first module. So first I'm going to install min search, which is a simple in-memory search engine. I actually think I already have it, so I will skip this part, but you will, if you don't have it, you need to install it. Then the second step I'm going to do is fetching our FAQ documents and doing some preparation. So this is how our documents look like. Let's take a look at the second document. So here we have question answer documents. So we have a question: can I still join the course after the start date? And the answer is yes, even if you don't register, you're still eligible to submit the homeworks, etc. We have seen this example many times. So we have many documents like that. And what we want to do is use index these documents, put them in a searchable database, and retrieve this information when we do our RAG. And I see a question if RAG is somehow similar to MCP. These are the very different things. So RAG is what I explained now. We will talk about MCP later towards the end of this video. So MCP stands for Model Context Protocol, and RAG stands for Retrieval-Augmented Generation. If you want to learn more about RAG, I suggest you check module number 1. There you will see a more detailed explanation of all these 3 steps in the RAG function. Right? And then let's implement the step number 1, which is search. So we use min search, the min search library. The difference between this, so in the previous videos we used index, and now we use appendable index. So appendable index is the same as index, except we can add documents to this index after we did the first iteration. So if we do search, can I still join the course? Then it gives us the documents where that match this description. Or match this query, right? So then we have this search function that we implemented together that only performs search within the data engineering course questions. Can I still join the course? And then it gives us 3 documents. One thing that is new is we have this new parameter for the search function, output IDs. And here we have IDs that uniquely identify these documents within our search engine. Right? We will later use them. Right now it's not important, but for you just to know that we have this thing too. Okay, so this is how we do the search. then the next step in our RAG is here we have 3 steps: search, build prompt, and LLM. So now let's build the prompt. So this is our prompt. I'll keep the question here, so then I don't need to type it every time. And here is the prompt. So this is the same function we saw previously in module number 1. And this is the prompt. Your course teaching assistant, answer the question based on the context from the FAQ database. Use only the facts from the context when answering the question. One thing that changed since last year when I was recording the previous video was that now it seems everyone is using XML kind of tags in the templates, which makes it clear for the model that here in this example that the context ends, right? So here we have the beginning of the context and the end of the context. We have the beginning of the question, the end of the question. So it's more common to see these days this XML like markup in the templates. So this is what I'm using here in the template, but otherwise it's the same function from module number 1, right? So this is our template, and now if we use it, question we already know, right? Search results, search question, and then we can build prompt, question, search results, print prompt. So this is the prompt we're going to send to an LLM, and then the LLM will give us the answer to this question using this context. Should be nothing new to you. So this is a classical example of RAG. So this is the function we're going to use. So we use OpenAI here, we use GPT-4o mini model, and we simply send the prompt using the chat completions API. And this is our RAG function. So first, before we use the RAG function, let me actually put it separately. We'll use it later. Right now, what I want to use is simply invoke the LLM prompt, and print the answer. So this is our RAG. We just implemented it in a couple of minutes. This is the answer that the LLM gives. Yes, you can still join the course after the start date. Even if you don't register, you're eligible to submit the homework. And then we put everything together. So now we can test other things. How do I install Kafka? Or how do I run Kafka in Docker? And then we should get back the results, right? So this is our RAG. There are some limitations, or how to say. So RAG is very good for cases when we have the knowledge base and we cannot use anything else. So we always must answer the question from the student, from the course participant, or whoever, from the user, only using the context. But sometimes there are some things. So for example, let me try this question. What if our student has a question, how do I patch under FreeBSD? I mean, we don't cover this, so it's a little off topic. But in this case, if somebody had a question like that, our assistant, if we want our assistant to be able to answer questions like that, questions that are not in our database, our assistant cannot do this. But if we just ask an LLM, if I send the same thing to an LLM, then LLMs, they usually know these kind of things. So they know what is KDE, what is FreeBSD, so they should be able to provide the answer, because LLMs are quite knowledgeable. They already know many things. And if in our case, if we want to build an assistant that is capable of answering generic questions and also use our database, we need to use something different. And this is where our Agentic RAG comes into place. So in this case, we can let our system, our assistant, decide if it can answer the question itself, without using any external knowledge base, or it needs to look up the knowledge base. I want to quickly illustrate this because I think it's a little abstract what I say. So let me just do that. So let's start with a typical RAG. So we have our user. A user has a question. So there's a question. Can I join the course, right? So in the case of RAG, what we do is we go to our knowledge database. I'm not really good at drawing these things. So we go to our knowledge database. I'll call it KB knowledge database or FAQ, right? In our case, FAQ. And then we get back some documents, right? So we get back, I don't know, like 5 documents, right? So it's document 1, document 5, right? And what we do is we put these documents, it's actually, we don't show them to the user, we'd rather put them to a prompt. So we have a prompt here. Prompt, answer the following question using the context, right? And then we have question here, and we have context. And when it comes to the context, this is the question, this is the context, right? So this is what we do. This is creating the prompt, the second step. Right, and then the last step is actually sending this to an LLM. And the LLM is giving back the final result to the user. So this is our classical RAG, right? So this is what we do. This is what we show in the course, right? But what if the answer, the question is something that our knowledge base does not contain? Could be, I don't know, let's just use Q. Could be any question. So what we want our system to do is make a decision if it needs to actually query our, do we need FAQ? So our system needs to decide if it needs FAQ, then it follows this route, this way. If it doesn't need FAQ, then it just gives the answer immediately, right? In case, how do I patch KDE under FreeBSD? It's not relevant to the courses, I guess, but like in this case, if this knows how to answer this question directly without involving a knowledge database, then it just does that. Otherwise, it does this. It does the retrieval, it builds the prompt, it calls an LLM, and then gives back the final result. So this is path number 1. So this is no, we don't need FAQ. And if we need an FAQ, then this is the path we follow. Right? So we want our system to make this decision. And if we do this, it becomes agentic RAG. So not just simple RAG, but agentic RAG. And let's talk a little about agents. So agents are things that interact with environment. So let's say we have some environment where things can happen, and then we have an agent here inside this environment. Let me use a different, so this agent, and there is some environment. So what agent can do is agent can observe the environment and perform some actions. So for example, the environment could be our chat application and the questions from the user, and then agent can perform tasks or actions. Agents have actions, and then agents also have history of past actions and memory of past actions. So it knows what kind of actions it performed in the past, and what was the result of these actions. So this is an agent in the classical sense. So for example, if we want to build a robot that can navigate, I don't know, Mars environment, right? So then the robot, this is not something we use LLMs for. This is just general AI agents. So they use reinforcement learning for the agents to learn what kind of actions it perform, and it uses some knowledge of what has happened to make the best decision. So agents can make decisions independently, and this is the relevant part. This is what we care about. So because we want, in our case, we want our system, our AI assistant, to make a decision if it needs to look up something in the knowledge base, or it can give the answer immediately, directly. And just by doing this, we kind of have an agent. In this case, the environment is the dialog, and the actions are to perform search or not to perform the search, right? So it's like the simplest possible agent, and this is something we can implement right now. And actually, to implement this, you don't need a lot. We already have this prompt. What we can do is we can change the prompt slightly, and we can say, if you want, you can look up things in our knowledge database, but if you can already give the answer, then just give the answer, right? So we can let it decide if it wants to give an answer immediately, or if it needs to look up the database. So now let's implement this. I'll call this section Agentic RAG. So this is what we are going to do. So our prompt becomes a little more complicated. So let's walk through this prompt. So I took, I don't know, maybe 15-20 minutes to build this prompt. But the idea, I explained to you the idea. So now we want the LLM to make a decision. And it starts like the previous prompt. I say you're a course teaching assistant. You are given a question from a course student that you need to answer with our knowledge, with your own knowledge, and provide the context. So here I say that you can use your own knowledge. So here we put the question, we put the context. This is the same as before, but I give extra instructions. I say if context is empty, so if there is nothing in the context, you can use our FAQ database. In this case, if you think that you want to perform search, output this thing. So it says perform search and explains, we ask it to explain why we think it needs to perform search. But if there is already context, then, and if it can answer the question using the context, then use this template. And we say here, put your answer, and then say, okay, the answer, the source for this answer is context. But if there is nothing in the context, you can use your own knowledge to answer this question. So we are at the state, let me show you. So here, so we ask a question, and then we look up something up in the knowledge database, but the documents we get back, they don't contain the answer. Then we can let the LLM actually answer this question, try its best to actually answer this question, even if context is not relevant. Of course, it depends on our application, so we can tweak the prompt according to the requirements we have. But in this case, I use the prompt that if there is nothing in the context that you can use to answer this question, still try your best to answer it. Yeah, and it should, I see a comment, shouldn't it be you cannot use the FAQ? No, it should actually be you can use our FAQ database. If context is empty, it means, let me show you. So here, agent can perform some actions, and it has history of past actions. So here, So here, we give it a question, and then the history of past questions is kind of saved here. So if we haven't done the search yet, then the context is empty. We haven't performed the search yet. If we perform the search already, then the context is already filled, right? So the LLM, when we send a prompt to it, we'll know if it has asked previously to perform search or not, right? Maybe it will make sense when we actually start trying to use this prompt. So let us do it now. So this is the prompt. And so the question we have is, can I still join the course, right? So ideally in this situation, yeah, let's try a different question. How can I run Docker on Windows 10? Let's try this question. Ideally, I think the LLM should decide to just give the answer immediately without consulting FAQ. But we will see now what it makes. So what kind of decision it makes. Because for the question that we asked previously, can I still join the course? It needs to look up in the FAQ. Right now, we want to find a question that it can just answer immediately. Right, and then we said at the beginning context is empty. Right, and now let's build the prompt. Prompt will be prompt template, format. We have our question, right? Question is question, and context is context. And so this is our prompt. Prompt. So here we have question and context is empty. Okay, so now let's ask our LLM. So let's see what it actually replies. So we can see that LLM was able to answer the question immediately. It says, source of knowledge: to run Docker on Windows 10, you need to install Docker Desktop. Here's how you do this. Okay, so this is what I expected. So I expected that it would be able to just give us the answer. What if the question is, can I still join the course? Right, the one we talked about previously. Can I still join the course? So in this case, I expected to, yeah, so the question asks about enrollment status. So I have no idea what this what this user is talking about. So let us look up the FAQ database. So now it makes a decision, and this decision is now we need to perform search. Okay, so now what we can do is, let's say it's answer JSON. Then I'm going to import JSON library, and now I'm going to parse it. JSON load as answer JSON, something like this. Right. So now it's a dictionary. So we have action here. So what we can do is some sort of if statement. If answer equals action, then perform search. And we already know how to perform search. To save some time, I am just going to copy it from here. So yeah, we do search, then we build context, and we build prompt. So for build context, we don't have this function yet. We have a function that we call build prompt. I will quickly implement this function from this build context. For this, we only need search results, and we just return context. I will also have strip thing at the end. So, oh, it's build context, sorry. Yeah. So our question is, can I still join the course? Then this is, we perform search, right? Because the action is search. We get our context, and we create another prompt. So this is our prompt. So now, can I still join the course? Then we perform search. We get some FAQ records, and we add these FAQ records here in context, right? So this is what we want to do. And now we have our final answer, which is LLM prompt. And now we just need to parse it. So it says action answer, source context, because it used context to answer this question, and it gives the question. So we went now this second way, and we looked up something in the knowledge database. We got back some candidates, document candidates, and then we did the usual RAG. So now we made our RAG agentic. So I'm just looking at the comments. Yeah, it looks like I have built agentic RAG. Yeah, okay, good. Good for you. So yeah, so this is our agentic RAG. It's still simple. We still didn't do anything super special. We just adjusted our prompt and we let LLM decide if it wants to, if it can answer the question immediately or it needs to query the knowledge base. Again, it depends on our requirements. In some cases, we want to be able to answer the questions from the users immediately without looking up the knowledge base. In some cases, we only want to answer questions using the knowledge base. In this case, agentic RAG maybe is not the best solution. But now I want to talk about agentic search. It's like agentic RAG, but we can perform multiple iterations. Let's say our question, the question we have, is something that requires a little bit of research, like how do I do well on module 1? Okay, one thing I forgot to do is just put everything together, but it's relatively simple. Well, let me just show you the code. So this would be like the entire agentic RAG put in one single function. So we do, this is the first step. We ask an LLM to make a decision if it wants to query the knowledge base or not. If the action is search, then we query. If the action is not search but answer, we give the answer immediately. So this is fairly simple. So I'll just skip that part and we go to this agentic search. So when it comes to agentic search, the questions that we want to answer with agentic search are broader. So sometimes we require multiple iterations of search. We want to ask, we want to make multiple queries. We want to think what exactly we want to query. Because what we do so far is we take, can I still join the course? And use it as a query to our knowledge base. But maybe this is not the most effective query we can use for querying our knowledge base. Maybe the better query would be late enrollment politics or policy, right? So maybe this query would be better. So what we want to do now is ask our LLM to actually do a bit of exploration. So we give it a question from the student, then it first makes a decision if it wants to reformulate a question differently. And we also may ask it to send multiple queries to our FAQ database. And so this is what we want to do. And we also want to do multiple iterations. So for example, we make a few queries to our knowledge database, we get the context, and we see that this context doesn't really contain the answers we need. So then we may decide, or LLM may decide, to formulate the queries it sends to the knowledge database differently and then perform another attempt. And then we can do this for multiple iterations. So in this case, it's like something like deep research, but smaller, right? So this is what we want to do right now. This is what we want to implement. So it will be still RAG because we will still use our database, but it will just become a little smarter. So let's do that. So this is the prompt. Let me copy it. So as you see, by making it a little smarter, I meant our prompt becomes more complicated, more complex. We describe more things in this prompt. Let's take a look at this prompt. So yeah, it's multiple screens. And the more, let's say, intelligent, air quotes, your agent is, the longer the prompt will be. Because let's take a look at this thing again. So an agent can perform some actions, and it also needs to know the history of the previous actions. And we want to embed this all in the prompt. We want to say that for our agentic search, we can perform the actions we can perform are search, And actions, another action is answer using your own knowledge, and the third action is answer using the search results, right? So it can perform 3 actions. And the results, the memory, this history, are queries it has already tried on our FAQ database, and also the actions it tried. So let me just show you the prompt. Then once we implement this, it will become clearer what exactly I mean here. So you're a course teaching assistant, you're given a question from a course student, and you need to answer it with your own knowledge and provide context. This is the same as we had previously. But then I add more context here. So the context is built with the documents from our FAQ database, search queries. So I basically describe these things here, these variables, these things that we are going to fill in. The context is built with the documents from our FAQ database. Search queries are the queries that we used previously to retrieve the documents. So this is our history part. So we already tell it, these are the queries we used before. These are the results we got from these queries. So it knows that it does not need to attempt these queries again because it has already tried that. And previous actions contain the actions you already performed. So here we explicitly say this is the history of past actions. Then we say at the beginning the context is empty, and we give it an explicit list of actions it can perform. So for any agent you implement, you want to do something like that. You want to say, these are the things you can do. And so you basically give a very detailed explanation of things that are happening. So in this case, you can perform the following actions: search in the FAQ database, answer the question using the context, and answer the question using your own knowledge. 3 actions we talked about. For the search action, build search requests based on the context and the question. Carefully analyze the context and generate the requests to deeply explore the topic. So here in this case, I tell it to, when we get a question, it needs to think what kind of search query makes sense, and it formulates this search query. And I also ask it to look at the context, look at the results we already have, at the search results we already have, and think about other things you can ask to explore the topic deeper. And then I explicitly say don't use search queries used at the previous iterations, don't repeat previously performed actions. And what is more important, because we want to have multiple iterations, we don't want to keep iterating forever. At some point, we want to stop. So here we explicitly control it. We say, don't perform more than, let's say, 3 iterations. And we also say that the current iteration number is 0. So if it sees that there are 3 iterations and the current iteration number is 3, we just ask, whatever, you already have the context, don't perform any further search actions, just do your best to answer the question given the information you already have. And then finally, we specify the templates for different actions. So for the search, we ask it to provide some keywords. For answer context, we say, yeah, just give your answer. And for answer with your own knowledge, we ask to follow this template. And then finally, we fill in the variables. Right? So this is a prompt. I spent some time building this prompt, tweaking it to make it more or less work. So this is more like art and science. You just try different things, you test them, and you see what works. And of course, it's quite useful to evaluate your prompts, and this is something we will learn in later modules, in the evaluation module. But for now, what you can do is just use your gut feeling and have a few queries and test these queries and see what works, what doesn't, right? And then later we will learn about a framework for doing this in a better data-driven way. Okay, but this is what I did. So I just used my gut feeling and I used trial and error and saw what works. And I built this prompt. So let's test it. So for it, we need what? We need a question from the user. How I do? So let me copy it here. So how do I do well in module 1? Then, sorry, I got distracted by a message. So this is the question. Then we have max iterations and the iteration number. So then max iterations, let's say we want to perform 3 iterations. Then iteration number is, we start with 0 iterations. So at the beginning, the context is empty. So it can just decide, okay, if it wants to make search, it makes search. If it doesn't, then yeah, just gives the answer. So at most, it can perform 3 searches. But in total, I guess it will be 4 times we invoke LLM at most. But of course, we can start with 1 and it will be fewer iterations. If we exceed the allowed number, okay, so next, what do we have? Question, we already have it. Search queries at the beginning is empty. Context is also empty. And previous actions, so this is actually search results, it's empty. And previous actions is empty. And now we need to build the prompt. So prompt will be prompt template format. Let me just copy it from the document. I think it will be a little faster. So this is what we do for the prompt template. Let me just slightly change it. I will use here these variables. So this is what is happening. So here the question is here, this question context is, yeah, we need to build it from build context from search results. So search results is empty, that's why it will be empty. Previous actions is empty, search queries are empty. So what we will have is print prompt and empty prompt. Right? So here we have question, all these things are empty. Here we have 3 iterations and the current iteration number is 0. So now let's ask LLM prompt. Oops. So yeah, it says perform search, and so it gives some reasoning why, and then the keywords it uses module 1 success tips, how to excel in module 1, and module 1 study strategies. Makes sense, right? So it formulated the student question, the user question, reformulated in search query terms. Because when you go to Google, you don't typically use how do you do well in module number 1. You rather use something like this. So you don't use a question, you rather use a keyword, right? So we have these keywords, and let me parse it. So now it's more structured, right? So we see that these are the keywords. So the action, first of all, the action is search, and these are the keywords we need to perform. Keywords. So now we need to perform search, right? This is what I want to do now. So I'm going to do a simple for loop. Keyword, and will be search result, search. So I'm going to just execute the search function we used previously. But we also need to start populating these things. So for search queries, we want to append this search query because we want to keep a list of all the search queries we previously used. And then we also want search results, add all the search results we had so far. So now our search queries will contain this, and our search results will contain this. Yeah, so these are the search results. And if we look at the length of this, it's 15, because we had 3 queries. For each of these queries, we get 5 results. So in total, it's 15. But we also know that some of these things are probably duplicates. So I think 112, and I think we have 112 again. Because we have similar keywords, similar queries, it makes sense that the results we obtain are also similar. So in order to save some money when we send these things to an LLM, we want to remove duplicates. For that, I'm just going to use this function, deduplicate. So this function, I'm going to put it, let me put it here. So it just simply goes through all the results it has, and it uses this ID field to deduplicate. So if it has seen already a document with this ID, we skip it. And so this is how this function is working. So now what I will do is I will simply use this function to deduplicate results. And now if we look at the length of the function, it's 6. So there was a lot of overlap between these documents, but actually because we created multiple queries, we were able to retrieve one extra document, which could be useful. So our context now is 6 documents, not 5, right? And now we make another iteration of the prompt. So we also need previous actions, right? So previous action would be this answer. So let me show you previous actions. So the action was search. Okay, so now let us build the template. I'm just going to do this. So iteration number changes. Right now it's 1, the rest is the same. Okay, so this is our prompt now. So we have the question, we have search strategies, search queries, sorry, then we have the context. So very similar to our initial RAG, but more complicated. And now we can basically keep doing the same thing until we reach the max number of iterations or until the action is answered. So right now I'm just going to do this manually. So let's see what the answer is. So it actually wants to perform more search. And you see, it now says study tips for Docker and Terraform. So we didn't ask about Docker and Terraform, but because it saw this in the context, it saw that the context is talking about Docker and Terraform. And Docker and Terraform is what is covered in module number 1 of the Data Engineering Zoomcamp. Now it added this thing. So it explores the topic. And we need to perform, I am simply going to re-execute this one more time. So now keywords, we do search, we duplicate. Now iteration number is 2. Now let's see what is the answer. So probably right now it should just give us the answer. Yeah. So now if we parse it, this is the answer we get. Let me actually do this. Answer. Okay, to do well in module number 1, focus on Docker and Terraform, consider the following strategies. Cool. So we had no idea that this, or at least an LLM from the first iteration had no idea that the module is about Docker and Terraform. But now, because it saw it in the context, it explored this topic deeper, and then it said, okay, to do well in module number 1, you need this, this, and that. So this is a good example of agentic search when we explore the topic and do different things. And in this particular case, we used our FAQ database, but imagine if you use something like the entire internet. So there are things like Brave. So Brave Search API is something like Google, but a different search engine, and it has an API. So what you can do is you can just build this search, agentic search, using the entire internet. So you can go as deep as you want and explore any topic you want. So this is how you build, how did we call it? Like deep research. So this is how you do this. Okay. So I see some questions. I think let me answer these questions at the end because it's a bit distracting now to look at them. Okay, I don't see anything that is related to the content. I mean to the code. So here I just showed you how to do this in a Jupyter notebook, but we actually want a function. So here is a more complicated version of this. So let me actually explain that. Because here, what I did is I just executed and re-executed the cells. But what we want to have is actually a for loop, a while loop. So we want to perform this while loop. So we want to keep asking the LLM for more and more and more until it decides to stop. So here we have 3 iterations again, like we did previously. The question I have here is, what do I need to be successful at module number 1? So this is a more extended version of the question we already looked at. And this is basically the same code as we had previously, except we have a while loop here. So here we ask an LLM, we parse the answer, we append it to the previous actions. Then if the action is not search, if the action is answer, then we break the loop. So then the answer is ready, we just present it to the user. But if the action is search, then here I think this is how I do the duplication of search queries. Well, we explicitly asked it not to create duplicates. Well, yes, I thought it's a good idea to do the duplication. Okay, then we do search, and we do the duplication of the search results, and then we do iterations. And if we reach the 4th iteration, for some reasons, if LLM decided not to give us an answer, even though we have exceeded the maximal number of iterations, if it still didn't give the answer, then we just simply break. So let's see what it's doing. So this was iteration number 1. So this was the prompt. So this was the action. Now iteration number 1. So it was the 0th one. So yeah, so now in this case, it used best practice for learning Docker, best practice for learning Terraform. And now, did it give the answer? Oh, our context becomes very long. You can see here, right? Okay, where is the? Let me just check it here. Okay, so this is the answer. And how many iterations we made? What was the variable? Iteration. So it made actually 3 iterations. So it decided to make another request. So it performed 3 iterations in total. And then at the end it's okay, like enough exploration, just give the answer with what you have already. Okay, this was agentic search. And now you have seen from this prompt that it becomes rather cumbersome, right? So it's, I don't know, 3 screens. And then imagine you need to implement a different agent. You need to implement an agent that, I don't know, books flights. And yeah, so for example, you say, hey, I'm traveling from Berlin to London on these dates, book me something. So what the actions of this agent, what can be is for a specific date to look up available flights, right? And then book a specific flight. And the way you interact with the user would be, okay, first you understand that this user wants to travel. So you understand that the action you want to perform is look for available flights on this date when the user is flying to London, and the flight back on the date when the user is flying back, right? So it needs to perform these actions. And then the final action is actually booking, right? So you would need to list all these things here, list all the formats here, think of all the corner cases. It becomes problematic, right? So you would need to come up with a prompt every time you need to perform a new agent. You need to describe all these actions. You would need to describe all these actions, like how exactly these actions, the output of these actions, then you would need to parse it. You would need to build like if statements. If action this one, execute this function. If action is like that one, execute this function. It becomes quite cumbersome, right? So it's not ideal from the maintenance point of view. So if you even like need to change something here, if you want to add a new function here, a new action, let's say we want to add an action that adds something back to our FAQ. So if I interact with a conversational agent, and then I find an answer to a question that is not in the database already, but I want to add this to the database, then adding this action here would also be difficult. That's why people came up with frameworks for doing this, and eventually it became what we call right now is function calling. You may sometimes hear another term tool use for that, and the idea here is instead of manually define all the actions, what you can do is you can say, okay, these are the available tools I have for this particular user query, so you can use them, right? So it becomes a little easier to maintain, and then we now become reliant on internal implementation of that. So OpenAI implements that. So in OpenAI we can have function calling, and I'm going to show you how to do that. So I think this is okay. So this is agentic search function, but yeah, I want to show you this. So we have this function. We have the function search, right? And what we did previously is we just say, okay, here is an action that you can perform, search, and we added an if statement where if action is searched to that, if action is not searched to that, right? So we have to do this. But what we can do instead is describe what this function is doing, and then we let the LLM decide when it wants to invoke this function. So we just can list all the functions that are available for the LLM to use, and if it thinks that it needs to use one of them, it just tells us. Right? So this is the idea behind function calling, and the way we describe the function is like that. So we need to follow a certain interface for describing this. So let's say we call this a search tool, and we say that the type of this tool is function. The name of this function is search. The description of this function, this is what it's doing, is search the FAQ database. And then, of course, we also need to tell it what kind of parameters, what kind of arguments this function has. So it has one parameter, query, and the description is search query text to look up in the course FAQ, right? So now, when we give it a prompt, we say, how do I do well on course number, on module 1? Then it says, okay, I don't know how to answer this question, but I have this tool available, tool at my disposal that I can use. And this tool can perform the search database. Because I don't know how to answer this question, how about I can try to use this tool? So this is the reasoning behind. Under the hood, what is happening is the SDK of OpenAI is building a prompt like we are doing, maybe in a slightly more complicated way, but at the end there is one prompt, one gigantic prompt that is actually sent to an LLM. But we don't need to worry about that. The SDK is handling that on our behalf. So let me show you how we do this. So we use a slightly different API this time. So previously we used chat completions API. Here we use responses API. And remember, so what we did previously was that we put everything into messages, like the entire prompt was just one user prompt. Now we can split them into a developer prompt, also known as a system prompt, and user prompt, user question. So the user prompt is how do I do well in module 1, and developer prompt is all the context, all the instructions we give to our assistant. We say, there will be a question from a student, and this is how you need to handle this question. So say you're a course teaching assistant, you're given a question from a course student, and your task is to answer it. Right? And then we also say that here are the list of tools that you can use to handle this question from the student. If you need, use them. If you don't use them. Right? Then we execute this. Again, I didn't execute that. So we have this search tool, the description of the search. So we send this query, and the response from an LLM is, I actually don't know how to answer this question. I don't know how to answer how do I do well in module 1. But since I see that there is an available tool that I can use, I can just invoke this tool, and perhaps if I do this, I will get an answer to my question. So here it says, I want to execute the function with the name search. And the arguments I want to give to this function is module 1 tips. And you can see that it actually internally, it translated the question from the user into a search query, right? So we didn't need to tell it explicitly to do that, although we could add this to the system prompt. But because it is smart enough to figure out that if we want to perform search, we don't just verbatim copy the question from the user, we turn it into a search query, right? So this is what I did. Yeah. So right now, what we need to do is just simply parse this. So I'll call it calls. So you can see that this is a list. There are multiple things, right? And because it can decide to perform multiple calls, not just one. But in this particular case, we have one call. So this is our call. In this call, we have name. So this is our function. I'll call it f name, function name. And we have arguments. So it's a JSON string, so I need to parse it. And this is call arguments. So our arguments is this one. So the argument is query. The parameter, the value is module 1 tips. So now we can invoke this, and for this I will use a trick. So that we have this function globals that knows about all the variables we have in our environment. And if I do this globals f name, then I get, because there is a function with the name search, so I can just look up here the search, right? So let's say if I do something like this, then I get a pointer to this function, right? Or if I do something like this, global search tool, I get this dictionary, right? So this way I can refer to any variable I have in my namespace here. So what I decide to do is I just use fname here to get our function. So this is our function, and now I can invoke this function this way and use named arguments, right? So I just pass the arguments to the function f. It might be confusing if this is the first time you see this kind of magic. If it's confusing, you can just talk to ChatGPT and say, hey, I don't understand what's happening here. Can you please explain? And then it will become clearer what exactly is happening here. So it might feel like magic, but the idea is we have the name of the function, and using this name, we want to just get access to this function. And then using these arguments, we want to pass this to this function and execute this. And when we do this, we get some results. Right? So these are results of this function. And now, so now what happened is it returned us a request. So it's or how let me think how to say. So we sent a request to OpenAI. We say, this is the tools we have. This is the question from our user. And the decision from the model was, okay, so it seems I need to look something up in your FAQ database. So now it's our turn to react to that. So we react to that, we look something up, and now we need to again invoke the LLM, and we need to say, you asked us to invoke this function. Here are the results, the output of this function invocation. Here it is. What do you think you want to use to do next? So it may decide, okay, now I can answer the question, or it can think, I want to explore the topic deeper and perform some other actions. Right? So let's do that. For that, we need to have So we use these chat messages, right? So this is how our agent, remember, agent can perform some actions and knows the history of previous actions. So actions in this case are the tools we provide, and the history is all the previous chat conversation. So the previous chat conversation was that this is what the user asked, then the model thought it wants to invoke this function, and now we want to say the result of this function is this. So we simply add this to chat messages. Now our chat messages become this. So using this, the OpenAI SDK will form a prompt. We'll execute this prompt and we'll get back the answer. So this is the system prompt we have. This is the question from the user. Then the decision of the LLM to perform function call. Then this is the result of the actual function call. Okay. So, but I think I didn't do it the right way. So how do JSON as search, search results and do this. I will execute it one more time because I added some things that I shouldn't have added to chat messages. So now this is how it looks like. So output is actually JSON. And let us invoke this one more time. So I'm going to do this. I want to put it here. And let's see what the model answers. The model may decide to make another function call or can just give the answer. And in this case, it just gives the answer. Then we can print it. Output, I think 0 content, 0 text. Yeah, it's hidden under, like it's very nested. But here's the answer. So it made one iteration, and in this one iteration, it looked something up, and then it just gave us the answer. We can modify the behavior of the agent by changing the system prompt. So here we can say, hey, how about you actually perform multiple calls to our FAQ database? I think I should have an example here. So this is an updated developer prompt. So the updated developer prompt is this extra line. If you look up something in FAQ, convert the student question into multiple queries. So now we explicitly tell it, hey, like, there will be a question from a student, and your task when you want to invoke the search function, your task is to invoke it multiple times. So let's see if it actually changes anything. We can see that now there are two invocations, so it makes a decision to invoke the function search 2 times. And yeah, so we see that in module 1 tips for success and how to excel in module 1. And in this case, we actually need to have a for loop. So for call in calls. Then in case we have multiple tools, we need to do this magic that we did before. Okay. And then finally this thing. So I'll call it just results, not to be very confusing. So we just need to execute this in a loop. So what we did here, we executed this for this one, and we added everything back to chat messages, right? So it has all the history. It knows, okay, I made this decision to invoke this function 2 times, and this is the output of these functions or of these invocations. And now we can do the same thing. Probably now it will just decide to give us the answer too. And we can influence it by adjusting the developer prompt. So if we wanted to do deeper exploration, this is what we can do. This is what we can change. Okay. Yeah, so this is how you invoke functions. Now we just need to Again, so this is kind of experimental code. This is just just trying things and seeing what happens. Now we want to put this into, we want to refactor this code. What we also want to do is have some sort of chat-like interface where we ask the system something, it replies, but then we can do a follow-up question. So for example, here it says, yeah, this is what you do, what you need to do in order to be successful in module number one. But then we can ask, well, what about Terraform? What do we need to know about Terraform? And then it can use the previous history to answer the follow-up question, like ChatGPT would. And for that, we will need two loops. So I'll copy the code. I know this, what I do might seem a little complex. I see that we don't have a lot of time, so we have only 15 minutes. That's why I will not spend a lot of time explaining like every line of the code. Maybe this is something I will do next year when we re-record this video. But because you have all the code, if something is not clear, you can ask in Slack, but you can also try to understand it with ChatGPT. You can say, hey, ChatGPT, like this is the code I don't understand. Can you please help me? Right? So let's refactor it a little bit. So first of all, I want to use this handy function do call, which has all this logic. So now when we do our loop, what we do here is just do call the result, and we do this, right? So then our for loop becomes a little, like a lot easier. And yeah, I'm not going to execute that. Right now, I am just going to copy the next thing, is this one. Because this is what we want to do. So we don't know in advance what kind of output will be if the model decides to do a function call or the model is giving us the final message, right? So we don't know that. So that's why we need to do a check. We need to check if the type is function call, then we do the invocation. If the answer is message, then we just print it. And we can put this into do loops. Let me just do that. Yeah, so let me just copy the code and I will explain this code later. I know some of you don't like that. You prefer us to code along, but for the sake of time, I see we don't have a lot of time. I want to finish it rather than spending too much time explaining it. So let me do it this way. So I copy the code and then explain it. Okay, so I think that's it. Yeah, so this is just a cleaner version, I guess, of what we have done so far. So I have the developer prompt. Here I changed the developer prompt slightly. So the beginning is the same, but then I say use FAQ if your own knowledge is not sufficient. When using FAQ, perform deep topic exploration. Yeah, and then also, I think this is what ChatGPT is also doing, is at the end of each response, ask the user a follow-up question based on your answer. So I think every time I talk to ChatGPT, at the end it asks a question. So I wanted to mimic this behavior to here. So then the first thing we do is we put this we put the developer prompt, the system prompt in the chat message, and then we have this code. So it has two loops. Let me actually execute this code. You'll see what it's doing, and then I'll explain how do I do well in module 1. So I ask it, and now it's performing 2 function calls. So now it will aggregate all the results and give me the final answer. And I can ask a follow-up. So it asks what specific aspects of module 1 are you finding challenging? No, let's say Docker and Terraform. So now it's actually, you see, it's doing some extra lookups in the FAQ, and it will now summarize, this is what you do. So now we implemented an agent that can do function calling to perform search. And this is now an actual chatbot. So previously it was just you send a question, then it gets the answer, but it doesn't have the message history. Now it actually does. And so let me go through the code. So first we ask the question. So here we have the prompt, right? So where we input the question. If I say stop, it breaks the loop. So now it stopped. Then we put the question in the messages, and we have another loop inside. So the first loop is we loop and we ask the question of the user for input, and we break when the user says stop. The inner loop is this is when we send the request to ChatGPT or to GPT to OpenAI, and here we keep sending the requests until there is a message. So first time we send the request, it's only two invocations, function calls. Okay, we just invoke the calls. We append this. We have seen this code previously. But if it has a message, then we stop the loop. We output the message and we get the user the chance to ask something. Because what can happen is the system makes a function call. It makes a decision to make a function call, right? So then you make the function call, you send the results, and then it thinks, okay, actually I don't have enough information yet. I want to make another function call, and then it sends it in the output. It shows that. So that here you need to make a call again. So it's not, there's nothing to display the user yet, right? So in this case, you want to keep looping until there is a message. And once there is a message, you display this message, and yeah, you ask the user for the follow-up. Okay, so this is the simple code. And then I did a little refactoring of this code. So I put everything in, just scroll. So I put everything into a nice Python script. You can, like here, this document explains what I actually did. You can go through this, but I just want to execute the script. So this is what we have in the script. So in the script, it's just the same logic as I showed you here, but it has some nicer way of displaying. So it uses widgets for displaying. So we can see what are the function calls. It does some nice formatting of the output. And then we have this class called tools. So in this case, I just used a bit of object-oriented programming to refactor the code we have previously written. So the class tools is responsible for knowing about all the tools, and it knows how to make a function call. So instead of using this global magic, it just keeps a dictionary of the functions, and it knows how to invoke them. Right, and then we have the chat interface. This is what is actually doing, displaying and asking the user for input. And then we have the main logic with all these for loops, or with all these while loops, with asking GPT and so on. Right? And the way to use it, you can study the code. What I actually did is I took the code I wrote in Jupyter Notebook, and then I went to ChatGPT and say, look, I want to do some OOP here. I want to create this class and this class and this class. Please do it. And then after a few iterations, I arrived at this code. And then I think I edited it myself too, but mostly it was ChatGPT writing it. So, okay. So this is how we use it. So I import the script, then first I create an instance of the class tool, and I add the search tool. And then these are the tools that we have available. And now this is the same as we were doing previously, except now it's in a script. I say I want to create a chat interface. So this is how we display it. Instead of this, it can be a Streamlit app, for example. And then finally, I create the chat assistant with these tools, with this developer prompt, with this interface and this OpenAI client. Now I just do chat run. And now we can interact with this. So I can say, how do I do well in module 1? So now it's a slightly more beautiful interface than we had before. So like we have this collapsible thing with the function calls. And then this is the answer from the assistant. So it actually shows, parses Markdown and displays it as XML, as HTML. And then how do you, what are you finding challenging? Docker and Terraform. So now we will perform another function call. Yeah, I think here the instructions, I don't ask it to break the student question into multiple queries. Yeah, I don't. Like maybe I should have done this, because you can see that it makes it in one search, but it works, right? So let me type stop. And now, before we finish, I want to show you the last thing is how to add more tools, because we have now one tool, which is search. But what if we want to add something to the database? What we want to have another function, and this function would, let's say, we want to add a new record to our FAQ database, and we want to use a chat interface for that. So for that, we implement a function. Let me just create a new section here. Multiple tools. So I want to create a new function. So this function would be, do we have it here? So this add entry. So this add entry function, what it's doing, it's adding a new record to our index, to our search engine. So then we can have more data there, right? And we are here talking about our data engineering Zoomcamp, and here the question, and here the answer. And the section is user edit. So now we want to provide the description for this tool. So I call it add entry description. So then we have a function which is called add entry. The description of it is add an entry to the FAQ database, and then two parameters, the question and the answer, right? And both of them are required. And what I can do is I can just add another tool. The tool will be add entry. And here we have add entry description. So now if I, So now if I look at get tools, I see that there are two tools. First is search, another one is add entry. Cool. And now we have two tools. And now I just want to run the chat assistant, and I want to ask, how do I do well in module 1? So now it's performing the search. Hopefully. Yeah, it's how that's a strange name, formulating query, but whatever. And now say add this to the FAQ database. So now it invokes this add entry, and the question, how do I do well in module number 1? And this is the answer. And let's actually stop. This we have index. In index we have documents. And if we look at the latest added document, that this is how do you do well in module number 1. And this is the answer it gave. So this is how you can easily extend your agent. You can add more tools there, more functions. And this is actually it. This is what I wanted to show. I feel a bit tired, to be honest. Like it's been 90 minutes. It's a rather long workshop, and I know that the last part with function calling, I was pretty fast. So some things I didn't really explain well. So for that, again, you can ask it in Slack. You can talk to ChatGPT. Yeah, and now you can ask questions in the live chat. I will actually, for me, it will be easier to answer them. While you are putting your questions in the live chat, I just want to give a little summary of what we covered here. So I want to go through all the code. And so what we did is first we talked about our RAG, right? So we talked about the usual RAG. We turned it into Agentic RAG by making it, by letting it decide if it wants to look up in the knowledge base or not, right? And then we started exploring Agentic search, and then eventually we we used function calling from OpenAI. So let me go through the notebook quickly. So this is where we implemented the usual RAG. So we simply used the chat completions. We sent the entire thing as a prompt. And our prompt was rather simple. Here's the question, here's the context, give us the answer. Right? And then sometimes it wasn't able to answer the question, even though the model is smart enough to give the answer. So this is how we arrived at our Agentic RAG. So we here say, if you want, you can answer this question yourself. But if you don't know how, then look up it in the database. So we let it decide whether to go to the database or not. Then we talked about agentic search, which is more like exploration of different topics. And that's why the example we used here was more ambiguous, like how to do well in module 1. And here we explicitly stored previous actions, we explicitly store search queries. So then the model knows what actions it has performed and what it has not. So then it can make a better decision. And we did multiple iterations, and then at the last, we say, okay, like enough exploration, just give us an answer. So we implemented agentic search this way. And then finally, we had our function calling. So instead of us implementing this every time and trying to parse JSON, define the format, we just relied on OpenAI's interface, SDK, where we can just say, here are the tools that are available. And then the SDK internally, I don't know if we can actually see how it's doing this, but internally it's building the prompt where it puts all these things together. And then it sends this prompt to an LLM, and then it gives back the answer that we can easily parse. So there's a very structured way of presenting this. So we can simply do this, use this, and we know that, okay, in this case, we need to do a function call. And we put everything together in this nice interface, which I didn't really explain how it works, but then you can just go to this chat assistant.py, which lives here, and then yeah, here you can go through the code. But this is basically just a refactored version of what we have written here. And because it's easily extendable, and this is why in the first place we decided to do function calling, it's easily extendable. It was very simple for us to extend it, to add another tool, which is add entry. And then we were able to add a new entry to our FAQ. So that's the summary. Thanks a lot for your attention. Let me check if you have questions. So questions from Sparsh. Is this add entry tool currently implemented for the Zoomcamp FAQ? No, so right now this index is just an in-memory thing. So like when we add something back, it doesn't really add any, so it's not persistent. So when we restart the kernel, it will be gone. So it's not persistent. For that, we will need to have a persistent database, and it does not actually add this to the Google document. Yeah, that would be like the next level. So this is just an illustration how you can add more tools. This is a toy illustration, but I think it gives you an idea of what you can do. So the prompt crafting art seems surpassed from the use of OpenAI SDK or similar. I'm not sure I understand your question, Mr. Luca. But yeah, like here, this is just a convenient interface. But sometimes you want to have more control. Sometimes the LLM providers you use, they might not support function calling. So that's why I decided to show you actually the hard way, let's say, how when you start from just a simple prompt and implement it, and then to show how to use function calling to make it easier. Because sometimes maybe, let's say, if you use Grok, some old model from Grok, maybe it doesn't support function calling. So then in this case, you can just create a prompt yourself. Or I don't know how this function calling would work with things like implementing deep research. Maybe for this, you just need to do handcrafted prompt like we did in our example. So now you have all the tools or like all the different ways of implementing this. And now you can try and see what works better for you. Can we do this with a vector database? Of course you can. So the search function can be anything you want. So in this particular case, I used an in-memory in-memory index because this is the easiest to implement, but it can be anything. What's the best way to handle user input validation when ending new entries through a chat interface? Yeah, you have some sort of guardrails. So this is another thing we don't actually cover in the course, but the guardrail is something, let's say a user wants to add something that they are not supposed to do, or they want to ask something they are not supposed to ask. Then in this case, we add another step, is like filtering. We again use an LLM and we say, this is the input from the user, please make sure that it satisfies the requirements we have, right? And then, or this is something you can add in the developer prompt, in the system prompt, right? And then this way you kind of guard against these things that users are not supposed to do. You can have JSON structure, what to call in vector document. Okay, so it's not a question. Just to be clear, this search is just keyword search. Yes, this is just keyword search. This is a simple toy implementation just to show you how it works. And then in your projects, you can replace it with everything you want. So in this case, this is in memory. If I restart the kernel, everything will be gone. For some applications, it's fine if you index your documents at the startup and just keep them in memory. And this is the case for, where is it? Where is Zoomcamp? So this is the case for our project example. Like you don't need anything but in memory store index. But sometimes you want to actually preserve, like persist things across multiple sessions. Then you need something like, I don't know, quadrant. Is there a predefined list of function tools to use from OpenAI? And not that I know of. Wouldn't it be better to first look for an answer in the FAQ database before looking in the training information? I'm not sure I understand this question, but it really depends on your use case. Sometimes you want to answer the question from the user immediately without going to the knowledge base. Sometimes you only want to answer the question if it's in the knowledge database. So then you need to decide for your application, do you want the agentic component, the agentic RAG, or you just want the simple RAG? So you decide, and then based on your requirements, and then you implement it. Okay, I think that's it. I actually need to run now. So I hope it was useful. We will have homework for this. It will be here in this module. We will make an announcement. Right now, you can work on the homework for the workshop we just had yesterday. It's still not ready. We're going to prepare it and make announcements. And for that, that's the last thing I wanted to say. So thanks a lot for attending this, and I hope you enjoyed it, and see you soon. Goodbye.